Hi, my name's Caitlin Fabre, and today I'm going to talk to you about hot air balloons. And I'm doing a presentation called Up, Up, and Away. So, the history of hot air balloons. The Montgolfier brothers were the inventors of the first practical hot air balloon. The first flight took place on June 4th, 1783, in Paris, France. The passengers were a duck, a chicken, and a sheep. It only lasted like 20 minutes and then it crashed to the ground. The next big thing in history was on October 15th, 1783, that same year, Philippe de Rossier and Marquise d'Arlandes were the first human passengers on a Montgolfier balloon. The balloon was not tethered, meaning it was not connected to the ground by a rope or anything. The Charles hydrogen balloon was better than the Montgolfier balloon, or exceeded it, in time, in the air, and in distance traveled. It had a wicker gondola, which is the place where the passengers would go, netting, a valve ballast system, and it was the standard form of the hydrogen balloon for decades. Then, on June 15th, 1783, Pierre Romain and Philippe de Rossier were the first persons to die in a hot air balloon. Here you can see a picture of one of the first hot air balloons taking off. Now, how exactly do hot air balloons work? Well, hot air balloons are based on a very simple scientific principle. Warm air rises in cool air. The hot air in the balloon is heated by burning propane, the same substance used in cooking grills. And what happens is the propane will heat the air, which will go into the balloon. The balloon is actually warmer than the air outside of it, and it will rise. Now, to lift 1,000 pounds in the basket, you need 65,000 cubic feet of hot air. That is a lot of warm air. Now here, I get into a little more about the science behind why it goes up. Now, the warm air, like I said, it rises. But why is that? Well, warm air has less mass per unit of volume. The hotter the air is, the less mass. But what exactly is mass? Mass is a measure of how much matter something contains. So, now let's look at the parts of the hot air balloon. Here you can see I have a few pictures, and next to it I have the definitions. The skirt is a reinforced opening. The burners give off flame or warm the air. Those are the propane tanks I was talking about. The envelope is the colorful fabric part of the balloon that's filled with hot air. Now this fabric has to be fireproof or at least resistant to flames because it gets quite hot in there and it could melt. The basket, where the passengers go, it's typically a wicker basket. The parachute valve is on the very top, and there's a cord that opens and closes the parachute. And the parachute can control your altitude. So what do I mean when I say parachute? I'm not talking about what you think when you go skydiving. Well, a Kevlar cord runs from the valve at the top of the balloon down to the basket, through the center of the envelope. But what is its purpose? And by envelope, I mean the colorful fabric part of the balloon. Well, the cord opens the parachute valve at the top of the envelope. When the cord is pulled, hot air can escape from the envelope, decreasing the inner air temperature, which will cause the balloon to descend. Now, you can play with your altitude, because if you let some of the hot air escape, you'll go down. But then if you close the parachute again and heat it back up, you can go up further. Now, you can't quite steer a hot air balloon, but you can play with your altitudes and get caught in different winds. Then you can control where you're going by playing with the wind. Now, I did some experiments. My first experiment was a simulated experiment. I got it off a website, and I will put the link in the description below. As you can see here, I had three things: the burner, the container temperature, and the pressure that I was keeping track of. The simulated experiment showed how the temperature inside the balloon is directly related to the pressure. This is important because if you want the pressure inside the balloon, well, you want the pressure inside the balloon to be more than the pressure on the outside, or else the balloon will cave in and then you'll go crashing to the ground. At different altitudes, the pressure is different. So if you are at low altitude, you would want a higher temperature to raise the pressure. Because the lower you are, the higher the temperature. You can see this in my chart on the right here. So if the pressure outside of the balloon decreases, the pressure inside the balloon will increase, causing both the balloon and the temperature to go up. And you can see here the results of my experiment. Now my second experiment, I did this in real life. I physically did this. I wanted to see how the size of the envelope would affect the flight time and height of the balloon. And by height, I mean the distance it traveled upwards. So what I did is I shortened the balloon. I used a plastic bag, and I simply put the plastic bag over a toaster. And I held it there for a few minutes, same time every time, 50 seconds. And then I let it go. And each time I'd cut off 6 inches of the bag. 6 inches. You can see here my results. But I discovered that when you shorten the envelope, or the bag, you can shorten the flight time and height. I kind of expected these results knowing how hot air balloons work, because the more warm air inside the bag, the higher it goes. But because the bag is really small, it couldn't really hold much warm air, and so it made the flight short. And the things I kept constant were the burner temperature, which the burner was my toaster. I just kept that at the same temperature every time. The type of bag I used, you don't want different bags because some of these things can mess up your experiment and give you different results. The surrounding temperature, I did it indoors because if you do it outdoors, you get winds and all different stuff. Just be very careful when you do it indoors. The other thing I kept the same was time to fill the bag. So this is the end of my presentation. You can see some sources here at the end, and I'll also put the links to the websites in the description below. I hope this helped you learn a little bit more about hot air balloons. Thank you.